How to calibrate and use Model D sensors. D models are often used for measurements to objects moving parallel to the axis of the sensor, as shown here. Any side-to-side motion should be avoided, as it will destroy the calibration accuracy. D sensors have a double-valued function: a high-resolution, high-sensitivity near side, an optical peak, and a low-resolution, extended range far side. To start a new measurement, calibrate the sensor to your target's reflectivity by setting its optical peak to 5.0 volts. To set up the sensors for a measurement, mount the sensor perpendicular to the target and bring it into contact with it. Then slowly open a gap until the maximum voltage output is reached. At that position, adjust the gain controls until the output voltage reads exactly 5.0 volts. Reset the gap to the desired set point on either the near side or the far side, and the sensor is now set up for operation. Here's an example showing how to use a D-type sensor.
Hello, I'm Jerry Phillips, and today I'm going to show you how to calibrate a D-type sensor to the target that you are wanting to measure. Here we have clamped in this holder a D probe. It's actually a model D169 in a square tip. And here's the target, a diffuse target, dull aluminum target. So put this in front of the sensor and you'll look at the voltmeter, and we'll bring this target in contact with the probe tip, and we have a low voltage. If we open up the gap, what you want to do is first find what we call the optical peak. That's the point at which the sensor voltage output reaches its highest value. And as you can see here, you move it in and out, back and forth a couple of times till you find exactly where it reaches its highest value, which is right about there. And you hold the gap at that point and adjust the gain control to get exactly 5.0 volts. We hit it. Now, if you're most likely making a measurement on what we call the far side, which is at a distance or a gap that's much larger than the optical peak. So what you want to do is reset the probe or move the target away from the probe, and I'm going to do that now. And you can see as I pull back, open up the gap, the voltage is reducing. It's getting lower. If you put it to approximately 3.5 volts on the far side, this is pretty much the sweet spot of the sensor. It's the middle of its linear range. It's the place where the sensor has its highest sensitivity. Once you're set at the optical peak to 5 volts, I want to show you that if we slide the sensor at that constant gap back and forth, you can see the sensor output changes very, very little of the target as you scan across the target. So it's very, very nice and stable. The same thing is not true if you are trying to make a measurement to a target that has, say, light and dark spots mixed over its surface. And so we're going to switch the target and show you what happens when you try to make a measurement to a target that looks like this. Okay, so now we've fixtured the stone target, the white and dark stone target, fix it to some blocks, and we've got the stone perpendicular to the sensor. First thing we need to do, like with any D sensors, you find the optical peak and set that to 5 volts. So the stone right now is in contact with the sensor, and we're reading 2 volts. That's because the stone allows some of the light to penetrate its surface, and then it reflects back out, and because the light doesn't completely reflect off the front surface of the stone, the output does not drop to 0 when you're in contact. So now I'm going to move the stage away slowly to find that optical peak. Well, now we have the sensor gapped at the optical peak, which is only 2.1 volts. and we're going to bring that up to 5.0 volts. And that basically calibrates it to the level of reflectivity of the stone surface. And you could use the fine control to dial it down to exactly 5.000 volts there. Now, if you recall, when we move sideways, laterally, with a diffuse target, we have little or no change in the sensor output. But now, with this target being a mix of white and dark, watch how much the target changes. Now I'm going to slide the block at a constant gap, not changing the gap, just moving it back and forth. There's 200, so you'd see several hundred millivolts of change, depending on whether the probe's looking at a white spot or a dark spot, which makes sense because this is a reflectance dependent type sensor. So the thing is, and when you're making a measurement to this kind of stone surface, you can only accurately measure a single axis motion towards and away from the probe. If the probe moves across the face of the target, as you can see, the voltage is going to vary depending on whether it's looking at white or dark spots. So to use this sensor accurately with this kind of target,
you must absolutely avoid sideways motion.